Hello, in this video I'm going to show you how to create Pong inside Unreal Engine from a completely blank project. In this video you'll learn how to create a full game and how to set up things like input, enemy AI and more. And if you want the complete project files for this Pong game, check out my website, you can get them there. Hello, to get started I'm in the Unreal project browser, and if we just go to the game section, and for the template make sure to select a blank one. We're going to be creating our ping pong game from a completely blank project. For the project name, I'm just going to call this ping pong, and then I'll click create. So it's loaded up my Unreal Engine project, and normally when working in Unreal Engine, I like to just go to the content drawer and just dock it in the layout. That way I can basically access all the project files in my project. Now the first thing we're going to do is create a new level for our ping pong game. So inside of the content folder, I'm just going to right click, create a new folder, and I'll just call this maps. Then if I just go up to the top where it says file, I'll click new level, and I'm just going to select basic and then go create. Then we just want to save this level, so if we click the save icon, it will ask us where we want to save the level, and I'll just save it inside of the map folder that I just made, and I'm just going to call this level. We can save this. Now the next thing we're going to do is create a paddle that our player character can control. So if we just go to our content folder, right click again, and we're going to create a new folder, and this time we're going to call it blueprints. Then we just want to open it up and we're going to create a blueprint. To do this we can just right click, go blueprint class, and select a pawn. So a pawn is basically an actor that can be possessed and receive input from a controller. So we want to select pawn, and we just want to call this our paddle blueprint. Double click and open this up. So we're going to design a paddle character. To do this, we can just go to our components tab and go add and just select a cube. Then with the cube selected, if we go here where it says select and scale objects, just kind of change its scale so it kind of looks like a paddle. So I'm just making mine a bit thicker and a bit thinner, and I think this looks good. Then we also just want to add a camera to our paddle blueprint. So the camera is going to be how we see our character. So we just go add and then look for camera. With this camera, if we just select it and then go to select and translate objects, just move this camera up a bit and also just rotate it so it's facing down on the paddle. So I'm just going to rotate it like this, and that is good. We can compile this, and we're going to make it so we start the game off as our paddle character. So to do this, we need to create a new game mode, and in that game mode, we can choose the starting character for our game. So to create a new game mode, we can just right click and go blueprint class, and we just want to select game mode base. So this basically allows us to configure the rules that our game will kind of have. I'm just going to call this my ping pong game mode. Then if we just open this up, and if we just go here where it says default pawn class, this is going to be the starting character in this game mode. We just want to change this to be the paddle blueprint that we just made. We can then just compile this, close this, and if we just go over to window and select world settings, it's going to ask us what game mode we want to have for this level. If we just drag our ping pong game mode, and then in the level you're going to see this player start. This is going to be where in the world our player character starts. If I just click this play button, I should start the game as the paddle character, and we can see my camera is very close, so I'm actually going to move it back a bit. If I just open up my paddle blueprint, and I'll just select my camera, and let's just move it so it's a bit further away. We can compile this, and now if I go play, we can see my simple paddle character. The next thing we're going to do is add some controls so that we can actually move and play around as the paddle. To set this up, if we go over to the content folder, just right click and create a new folder and just call this input. Then if we double click and head inside here, right click and then go input and select input mapping context. This will basically store all of the controls that we're going to have inside of our game. Let's just call this the ping pong underscore input mapping context. The next thing we're going to do is create a control to move our player character. So to do this, we can just right click again, go input, and this time select input action. Call this the move underscore input action. Double click and open this up. And for the value type, change this to be an axis 1D float. You'll see what this does in a second. Save this, and then we want to head back to the ping pong input mapping context and just double click and open it up. We want to go to add new mapping and just select the move input action. So the next thing we're going to do is basically assign a certain button to perform the move input action. So whenever we want our player character to move, I'm going to make them either press the up or the down button, and this will make them move. So if we just go here to the keyboard icon, if we just select it and look for the up button. So when my player presses the up button, it'll perform the move input action. We also want to make it so if the player presses the down button, they can move the character. So we just go add new control binding, and this time look for down. For this one, we're going to go to modifiers and go add element and just select the negate modifier. You'll see what this does in a second. The next thing we need to do is just add this input mapping context to our paddle so the player character can actually use the controls. If we just go back to our paddle blueprint, go over to the event graph, and we're going to go to event begin play. So I don't have mine, so if I just right click and look for event begin play, this will basically fire as soon as our game starts, and the first thing we're going to do is add our controls to the game. To do this, we can just right click and look for get controller. Then from here we can drag off and look for cast to player controller, connect this into here, then just drag off as player controller and look for enhanced input local player subsystem. We just want to drag off here and look for is valid, and this will just check to see that we have a valid controller for our player. By default we will. Then once we've added this, we can just drag off here and look for add mapping context, and we just want to select the ping pong input mapping context, and that will add the controls that we set up here. Next, in some free space, if we just right click and look for the move input action, so whenever my player presses either the up or the down button, this triggered node is going to fire, and we're going to basically make it move our paddle. So to do this, we can just drag off here and look for add local offset, and we're going to look for add local offset cube. We're going to be moving our cube. Now we're only going to move our cube in one direction. If I go over to the viewport and just select this cube and go to select and translate, we're going to be moving our cube in the y-axis. So this green one here, we'll move it either up or down. Just make sure that you change the location of yours back to 0 if you moved it around. If we head over to the event graph, on this add local offset, we can just right click here and look for split structure pin. We're only going to be moving it in the y-axis. Now, if you remember earlier, when we set up the move input action, I made us change the value type to be axis 1D float. Because we did that, we should see this little green action value here. Whenever the player presses the up button, this value is going to be 1. If I just head back to the ping pong input mapping context, for the down button, we added this negate modifier. So whenever the player presses the down button, because we added the negate modifier, this value will be negative. So if we just drag off here, we want to multiply this, and we need to multiply this by a certain value. If we just right click and promote this to a variable, and call this player speed. So this variable will control our player speed. Just compile this, and for now, let's just make it 10. And connect this into here. So again, if I press the up button, this value will be 1, and then 1 times 10, this will basically positively move my character into the y-axis. If my player presses the down button, this value will be -1, and this will cause my player to basically move in the opposite direction in the y-axis. We can test this out if I just go compile, save, close this, and now if I play my game, when I press the up button, okay, so when I press the up button I move down, and when I press the down button I move up. That's probably because I've rotated my camera the wrong way. If I just head back to my paddle blueprint and go over to the viewport, let's just select the camera and just rotate it. We just want to make sure that our camera has a value of 0 in the x-axis. That's the correct way. So I think mine was just rotated incorrectly. So now if I go compile, save, and I play my game, when I press the up button, my paddle moves up. When I press the down button, my paddle moves down. So with this, we've created a simple paddle that my player can move up and down. Hello! So the next thing we're going to do is create a ball that the player can play ping pong with. To get started, if we just go back to our blueprints folder, right click and go blueprint class. This time just select an actor and just call this the ball blueprint. Double click and open this up. And then we just want to go to components and go add and just add a sphere. And for the sphere, we want it to simulate physics. Now if I just go compile and close this, when I place this ball into my level, it should fall down and start simulating physics. This is good. The next thing we want to do is just make it so our ball is locked in the z-axis. This will prevent it from falling down. So if we just select the sphere, go to details and scroll down and just check lock position, then go compile. This should make it so our ball can no longer fall down. It should just be in the air. Nice. Now the next thing we're going to do is add some impulses to our ball, which will force it to move. So if we just go over back to our ball blueprint and go over to the event graph and event begin play, we just want to drag in our sphere, drag off here and look for add impulse, connect from event begin play into here, and just right click here on the impulse and look for split structure pin. And we want to add an impulse to our ball in the x-axis, and we're going to make that impulse a negative value, that way it moves towards our player character. So we just open up the ball blueprint, and here in the x, let's just type in -1000, and also make sure to check veil change. If we don't check this, then the impulse force is not going to be that great. So make sure to do that. Then if we just go compile, close this, and if I go play, my ball should go towards the right and then hit my paddle. Nice. So I'm just going to move my ball a bit further, and we can see that again, and nice. The next thing we're going to do is fix our ball's bounciness. When I click the play button, when my ball hits its paddle, it kind of loses its velocity when it hits the paddle. We want to make it so when the ball hits the paddle, it still kind of keeps its velocity and just reflects back. So in order to do that, we can create a material. So we just go over to the content folder, I'm going to right click and create a new folder, and I'll just call this material. Then we just want to right click and go to physics and select the physics material. And just select physics material, go select, and we can just call this bounce material. Double click and open this up. And for the friction, we're going to make this 0. So this is going to be how much friction this object has when it hits something. We're going to make this 0. And also make sure that the static friction is 0. The next setting we want to change is the restitution. This basically reflects the bounciness of a surface. Basically, if this is basically 1, when it hits something, it's going to leave with the same bounciness that it hit it with. If this is a lower value, then it's going to kind of lose its bounciness when it hits something. So we want to make this 1 as well. We can also just kind of hover over each setting to kind of see what it does. We can save this. Then we just want to go over to our ball blueprint and just select the sphere, scroll down, and for the physics material override, just change this to be the bounce mat that we just made, so the bounce material. We can compile this and save it, and then we also want to just apply this to our paddle. So I'm just going to select my cube here, and for the physics material, I'm going to give it the bouncy material that I just made. We can compile and save this. And now I go play. When my ball basically hits my paddle, you can see the ball, when it hit the paddle, it kind of didn't lose any of its bounciness. That's exactly what we were aiming for. Okay, so the next thing we're going to do is add a couple of walls to our level. If we just go here where it says quickly add things to the project, look for some shapes and then select a cube. We just want to move this down, and then I'm just going to go to select and scale objects with the cube selected. We can also just press the R button to switch to that shortcut to scale objects, and I'm just going to scale and add some walls. So I'm going to add a wall here, and then I'm just going to press Alt and select this cube. That will allow me to duplicate it. So now I basically have some walls, and for the walls, also make sure to give them the physics material. So the bounce material that we made earlier, make sure that both of these walls have this. And then I'm just going to kind of adjust my walls so they kind of fit in the camera. So I'm just going to do that now. Okay, nice. Now I've added some walls to my game. The next thing we're going to do is add an AI which we can play Pong with. To get started, if we just select the paddle blueprint, right click on it and go duplicate, this will basically duplicate that blueprint, and we can just call this our AI underscore blueprint. Double click and open this up, and we can just delete all of the nodes inside of here, and also just select the camera and delete it as we don't need it for the AI. So the way our AI is going to work is we're going to make it so it'll basically follow the ball. To do this, if we just right click and look for the event tick node, so basically the way event tick will work is every single frame it will run this node, and event tick will make it follow the ball. To do this, we can just drag off here and look for set actor location, and we're going to make it so our AI will basically move from the location that it's at to the location where the ball is at. To do this, we can just right click and look for v interp to constant. What this node will do is it'll basically take in a current vector value, so we're going to basically get our AI's location, and then we'll make it move towards that target value, so we'll get our ball's location, and we'll make our AI move from its current value to the target value. How fast it will do this will basically depend on these two variables here, delta time and interp speed. For the delta time, we can just connect delta seconds into here, and for the interp speed, like I said, this will be how fast it takes the AI to move from its current location to its target location. So for the current value, we can just right click and look for get actor location and connect this into here. For the target value, if we just create a new variable and just call this ball reference, for the variable type, we're going to look for the ball blueprint that we made earlier and just select object reference. Then we just want to drag in the ball reference and just drag off here and look for get sphere. So if we just scroll down, and we want this one. So inside of our ball blueprint, we basically want to get the location of the sphere. Then if we just drag off here and look for get world location, now we only want to basically make our AI move to the ball's location in the y-axis. So only in this green axis here. We don't want it to move in the z or the x here. I'm just going to change this back to 0. So for this, if we just right click on it and look for split structure pin, and for the target here, if we just right click on it and go split structure pin and just connect y into y, then we just want to copy this get actor location, paste it, so Control C, Control V. Then if we just right click here and split the structure pin and connect x into x and z into z, that way our AI will basically maintain the locations that it has in the x and the z axis. For the interp speed, if we just right click and promote this to a variable and just call this AI speed, we can compile this, and for now let's just make this 500. We can play around with this later. Then we just want to connect this return value into the new location, and event tick, it will kind of make our AI move towards the ball. If I just go compile, close this, and then drag my AI somewhere into my level, initially this is going to fail. So if I just click play, when I stop playing my game, we can see I get these error messages saying blueprint runtime error, access none trying to read the property ball reference. Basically, we're getting an error because my AI is failing to get an accurate reference to whatever the ball is. So in order to get an accurate reference to the ball, what we can do is just go back to our ball blueprint and event pick and play. We just want to drag off here and look for the get actor of class node. So this one, get actor of class, and the actor we want to get is the AI blueprint. So I'll look for AI blueprint. So what this node will do is it'll basically get the first actor with this class. We only have one AI on our level, so this will basically just get the first AI on our level and create a reference to it. We just want to right click and promote this to a variable and call this our AI reference. Connect this into here, and then we just want to drag off this AI reference and look for set ball reference and drag off here and look for self, and then connect this into here. So basically telling the AI reference that this ball wants to be its ball reference. We can just compile this, go back to our AI blueprint, and also on event tick, if we just drag in the ball reference, get it, and just drag off here and look for is valid, and just connect this into here and is valid into here. This will also prevent the error message, so only if we have a valid reference to our ball will basically make our AI move towards it. Okay, nice, we can test this out. So I'm just going to go compile, close this, and let me just move my ball so it kind of starts up a bit, and the AI should move towards it. Nice. So let's see if I can just hit the ball and the AI will kind of move back. Okay, so I kind of hit it like down, and as we can see the AI kind of hit it down as well. Although seems there are a couple of problems. I don't think I made my walls high enough, so I'm just going to make them a bit thicker. And then also another problem, both the player and the AI can kind of phase through the walls. So if we just go back to our paddle blueprint, and we just want to go to the bit where we add the local offset and just check this sweep box. This will basically check to see if our paddle basically overlaps something when it's trying to move. With the sweep box enabled, it will kind of block our paddle from moving. And if we also just compile this, then go over to the AI blueprint, make sure to just check the sweep box here as well. But for this to work, we also just need to drag our cube into the default scene root, so that is the main component. Then if we just go compile, this will prevent both our player and our AI from moving past our walls. The next thing we're going to do is make it so every time the player or the AI hits the ball will actually get slightly faster. Even though we set it so the ball will have as little friction and as much bounciness as possible, sometimes if we do hit the ball from like certain angles, it will actually become slower. So in order to make the ball become faster over time, if we just open up our ball blueprint, and we just want to right click and look for the event hit node. So the way this will work is every time our ball hits something, it will kind of fire this node. But for this to work, just make sure that the sphere is selected, and we scroll down and just make sure that you've selected simulate generate hit events. So make sure that this is checked. So event hit, every time our ball hits something like a wall or the player, will make it go a bit faster. So if we just create a new variable and just call this ball speed. For this variable type, change it to be a float and just compile this. And for the time being, just make this 1000 because that is the speed that we basically give our ball at the start. And when we hit something, we just want to get our ball speed, drag off here and look for add. And for the time being, let's just add 30. And then we just want to drag on our ball speed again, set it, and just connect this into here. So every time our ball hits something, we make the ball speed a bit faster. To actually apply this to our ball, if we drag in the sphere, drag off here and look for get physics linear velocity, this will basically get the velocity of our ball. And we just want to drag off this return value and look for clamp. And we want to look for this one, clamp vector size. This will basically make it so our ball will have a velocity which has to be between this minimum value and this max value. For the value, we can just drag in our ball speed, get it, and connect it into here. Then we just want to drag off our sphere again and look for set physics linear velocity, and just connect this into here and this into here. Then if I also just copy these two nodes here, so I'll go Control C and Control V, connect this into here, and then I'm just going to drag off here and look for the print string node and connect this into here. And now if I just go compile and play, whoops, so if I just go play again, every time I hit the ball, we should see it gets faster. So we can see it's 1090 in the X, then it's 11,020 in the X, and basically slowly but surely over time the ball becomes faster and faster. Nice. The next thing we're going to do is create a score system so that player 1 or the AI can score some points. If I just go back to my ball blueprint though, I'm just going to delete this print string and then compile this. Okay, so to display the score that the player and the AI have, we're going to create a user interface which will show this. So inside of my blueprints folder, I'm just going to right click, go user interface, select a widget blueprint, and I'll select user widget, and I'm just going to call this score underscore widget blueprint. I will open this up, and if we just go to the palette and look for a canvas panel and just drag this somewhere into the hierarchy. Then in the palette, let's look for a horizontal box and just drag this somewhere into the center here. just make it kind of this length and just select it, and for the anchor, just anchor it to the center of the screen. Then look for a text and drag 2 pieces of text into the horizontal box. For this first text, just select it, then go to padding and go to right, and just give this a padding of say 500. So as you can see, the padding is kind of pushing this text away from it. So we want there to be a bit of a gap between the AI score and the player score. And I'm also just gonna select both these text blocks and make them say 0. And we just want to go to font and make them a bit bigger so it's just a bit easier to see. So maybe 100 will be good. And I'll also just increase the padding to 700, I think. Okay, nice. We can just compile this, and the next thing we're going to do is kind of make it so this score will basically appear on the player screen. So if I just close this, and I'm going to go over to my paddle blueprint, and after I set up my controls, if we just drag off here and look for create widget, and the widget we'll create is going to be the score. We just want to right click on this return value here, and let's just call this our score HUD, and then we just want to drag off here and look for add to viewport, and then just go compile, and this will basically add that HUD to our viewport. Nice. The next thing we're going to do is set up some goals, and when the ball basically crosses one of the goals, either player will get a score. So I'm just going to right click and go create new blueprint class. Let's create an actor, and let's just call this the goal underscore blueprint. We can open it up, and for this, if we just go add, and we just want to look for a box collision and just scale it in the Y axis. Compile this, and then we want to go over to the event graph. Make sure that the box is selected, and if we just scroll down and go to on component begin overlap, if this ever overlaps the ball, we want to destroy the ball and then basically increase one of the player's scores. So when this overlaps the ball, if we just drag off other actor and look for cast to ball blueprint, then as the ball blueprint, we just want to drag off here and look for destroy actor, and then this should destroy the ball. Let's just test that everything is working, because we're going to kind of communicate with a lot of different systems. So I'm just going to go compile, close this, and then I'm going to add a goal here. And I'm just going to expand it because I think I made mine a bit too small. And then let's also just add a goal here. And I'm just going to move it so the ball starts up here. And if we just go play. Okay, so my ball was destroyed when it overlapped that invisible goal. I'm just going to move my camera up a bit so we can see that again. Okay, so just make sure that it's destroying your ball. So when this happens, we want to basically give the AI a score. So if we head back over to our score widget blueprint and go over to the graph, we want to create 2 variables. The first one we're going to call player1 score. And for this variable, change it to be an integer. So an integer is a whole number. Then if we just create another variable and call this player2 score. And then we just want to right click in this event graph in some free space. Just right click and look for add custom event and call this update player1 score. And when this happens, we just want to drag in player1 score, get it, drag off here and look for increment int. This will basically increase the value of this by 1. Then we'll do the same for player 2. Let's right click and create another custom event. So I'll look for add custom event and I'll call this update player 2 score. I will drag in the player 2 score, get it, and just drag off here and look for increment int and connect this into here. Then if I just go over to the designer, I'm just going to select this text here, and we can just go bind, and we can bind this to player 2 score. So player 2 is the AI, so I'm just going to select this. Then if we select this text here, we're going to go bind and bind this to player 1 score. We can then compile this. Then if I just go back to my goal blueprint, we want to create a new variable and just call this player 1 goal. And I'll add a question mark and make sure that this is instance editable and expose on spawn. And you'll see why we do this in just a second. After we destroy our ball, we want to drag off here and look for a branch, and we want to check to see if this was player 1's goal. If this is true, then what we're going to do is increase player 2's score by 1. If this is false, then we're going to increase player 1's score by 1, as that means they scored. But to do this, we need to get a reference to the score widget blueprint. So to get that reference, inside of this goal blueprint, on event begin play, what we can do is get a reference to our paddle that we're playing the game as. To do this, we can just right click and look for get player pawn. This will basically get the pawn actor that the player is playing the game as, and this is going to be the paddle blueprint. So because of this, we can drag off this return value and look for cast to paddle blueprint. Then we can just promote this to a variable, so we can just call this our paddle reference, compile this, and then if a ball goes in player 1's goal, we can just drag in our paddle reference and get the score HUD variable that we made inside of them, and then from here we can call the update player 2 event, and this will basically update player 2 score. And then I'm just going to copy these two nodes here. If this is false, that means player 1 has scored, so we can just drag off here and call the update player 1 score and connect this into false. So now if I just go compile, so now if we just close this and just select player 1's goal here, and just make sure to check this variable here so that we know that this is player 1's goal. So make sure that we have a check here, and then for this one it does not need to be checked as that's player 2's goal. Okay, so now if I were to just play my game, when the ball goes there, we can see the AI gets 1 point, and let me try and score 1 point against the AI. So I'm just gonna temporarily give it a very horrible speed of 1, and then I'm just gonna move it to the left there, and let's say I score a goal. I should get 1 point. Okay, nice. So with that, we've set up a simple point system. The next thing we're going to do is make it so when our ball is destroyed, another ball is spawned in its place. So to do this, if we just right click and create a new blueprint class, just select an actor and just call this the ball spawner blueprint. Open this up, and if we just go over to the event graph, we want to right click and look for add custom event and just call this spawn ball. When we call this event, we just want to drag off here and look for spawn actor from class, and the actor we're going to spawn is going to be the ball blueprint, and where we're going to spawn it, we can just right click and look for get actor transform and connect this into here. Then event begin play, we also just want to call this spawn ball custom event. We can compile this, and we just want to close this and then go over to our ball blueprint and just create a new variable and just call this the ball spawner reference. Change this variable type to be the ball spawner reference, and we want it to be an object reference, and just make this instance editable and expose on spawn. Compile this, then head back to the ball spawner blueprint. Then we just want to right click on this node and click refresh nodes. Because we made the ball spawn reference instance editable and expose and spawn, we can control the value of this variable when we basically spawn it in. And we just want to drag off here and look for self, so that way when we spawn a ball, we have a reference to the ball spawner. Now if we head back to our ball blueprint, we can just right click and look for event destroyed, and event destroyed, we can drag in our ball spawn reference, and then we can just call the spawn ball, and this should spawn in another ball. So we can just compile this and let's test that everything is working. So I'm just going to delete my ball And instead, I'm going to drag in a ball spawner, and I'll just click play. So when my ball is destroyed, we can see it spawns in another ball. The next thing we're going to do is make it so the ball will switch the side that it spawns the ball on every time it's destroyed. So first it'll spawn in on my player side, then it'll spawn in on my AI side. So to do this, if we just open up the ball blueprint, and we just want to go here to event begin play. Before we add this impulse, we just want to create a new variable and just call it switch. And make this variable type a boolean. Make it instance editable and expose on spawn as well. And we just want to drag it in and look for get switch, drag off here and look for branch. If this is false, then we're just going to spawn our ball with an impulse of -1000. If it's true, however, we can just copy this, and we're going to spawn our ball with an impulse of just 1000. Also, just make sure to select the sphere and make this the target. We can compile this. Then if we go back to our ball spawner, before we spawn our ball, we just want to drag off here and look for the flip flop node. So the way the flip flop node will work is first it will do A and then it will do B. So first we just want to spawn our ball. Just right click here and go refresh nodes. We want to make sure that this is left unchecked. Then if we just copy all of these nodes, Control C and Control V, then the second time the ball is spawned, we want to just make sure that the switch variable is checked. We can just compile this, and then let's test this out. So if I go play, first it spawns the ball on my side, then the AI side, so it's fair. And then one more thing I want to do, I'm just going to move my ball to the center of the screen, my ball spawner, sorry, and then I also want the ball to basically kind of have a random velocity in the y-axis. So I'm just going to right click and look for random integer in range, and I'm going to make the minimum value -360 and the max value 360, and I'm just going to connect this into y. This will convert the integer into a float, and then I'm just going to copy this and paste this here. That way the ball will not basically spawn directly in the center. It may have a variant towards the left or the right. So now if I click play, we can see the ball kind of spawned in at a slight angle. Oh, and it looks like I also forgot to give my AI its speed back. So I'm just going to make this, sorry, it was 500. Yep, 500. Okay, nice. So with this, we have set up a ball spawning system. Hello, the next thing we're going to do is make it so either player 1 or the AI will win the game. So if I just open up my score widget blueprint, and I'm just going to go to the palette and look for some text, and I'm just going to drag this text and I'm just going to place it here, and we just want to anchor it to the top of our screen and make sure that this is variables checked, and just call this the win text. And for the size of it, let's just make it 60. We then just want to go over to our graph, and if player 1 or player 2 score ever equals 10, that means they've won the game. So if I just drag off here and check to see if this ever is equal to 10, then we are going to have a branch, and we are just going to drag in the win text and look for set text, and we want this one, set text, and just make this say player 1 wins, and connect true into here. We can just copy all of these nodes and connect this into here. And then one more thing, if we just go back to the designer, select this text, and in the search look for visibility and make sure that this is hidden. So only when the player wins we will show this text. So then after I set that text, if we just drag it in again, whoops, we can actually just drag it off here, and then look for set visibility and just set it so it's visible. Then I'll just copy this and do the same here, and then to stop the game from basically moving about, we can just drag off here and look for set game paused. Just check this. I will copy this, and then this will basically pause my game. Okay, for testing purposes, I'm just going to make this 1. Oh, and sorry, my bad. For this one, we want it to say player 2 wins. So yeah, if player 2 score ever equals this, we want it to say player 2 wins. So let's just go compile, play and test this out. So I'm just going to let the AI win. Then it says player 2 wins. Or you can make it say AI wins. So with this, we basically set it up so either player 1 or the AI can win the game. The next thing we're going to do is kind of change the design of our level. Right now, this doesn't really look like the classic Pong game, although there are some tricks we can do to kind of make our game look like a classic Pong game. So the first thing I'm going to do is just select my camera, and right now its projection mode is perspective. If we change this to be orthographic, it's going to change it so everything is flat, kind of like a flat 2D camera. We can change how zoomed in it is by changing the ortho width. So the further away this is zoomed out, the further away the camera is going to be. So if I just go play, now everything is flat. The next thing I want to do is change the shadows. I don't really like how my paddle and the ball have shadows. So to fix this, if we just go to our outlier tab and look for the directional light, then in the search, if you look for cast shadow and just make sure this is unchecked, this will make it so our objects no longer cast a shadow. So the next thing I'm going to do is change the background. If we just go to our materials folder, right click and create a new material and just call this black_matte. Double click and open this up. Right click and look for constant 3 vector. And we can just connect this into the base color here. Double click here and you can change the color of what you want this to be. I want this to just be black though. We can just click apply to save the changes to our material. Then just drag this into our level. Or you can just select it and change the material here. Now if I click the play button, it kind of looks a bit weird, and that's because lighting is affecting our material. If I were to just go back to my material, select it, and change the shading model to be unlit, this will make it so my material no longer basically receives light. So I'm just going to apply this, and the lighting will no longer basically affect the material. We can also apply it to our white material, but right now I think it doesn't look too bad. So you can also make the material that the Pong and the ball use an unlit material, but I think it's fine for now. Also, you may have noticed designing our level is kind of hard and it looks kind of ugly with this lighting. So what we can do is change the way that we can view our level. If we go here and change it to be unlit, it's going to show us how our level looks with no light. There are also other view modes, so maybe we want wireframe, but we can just change this to be unlit. It makes it a bit easier, I think, but it depends on you. So now if I click my play button, this is how my game looks. Nice. I may need to move my paddles a bit back, but I think this is looking pretty good so far. And then one more thing I'm going to do just for visual flair is add a couple of dotted lines going between these two paddles. So I am just going to go here, quickly add things to the project, and I'm just going to go shapes and select a cube. Let's move it down, and for these, let's just make it so they have no collision. So if you scroll down, and for collision presets, make it have no collision, and I'm just going to make this kind of like that, and then I'm just going to create a couple of these and I'll make them display down the center of my game. Okay, so I added some dotted lines just to have that classic Pong effect, and I think it's looking a bit better. Oh, and one more thing, so I may kind of just change the win text color so it's a bit clearer to see, and I also just need to basically change it so they need 10 points to win. So let me not forget to do that. And then I will change this to be red. Let's compile this. Okay, the next thing I'm going to do is add a simple sound effect to my game, which will basically play whenever the ball is hit. So we just go to our content folder, create a new folder, and just call this sounds. Head inside here. And then I found this ping pong sound effect. I'll make sure to leave a link to the sound effect somewhere in the description of this video. It sounds like this. And if we just go over to the ball blueprint, whenever we hit it, we want to play that sound. So we just look for play sound at location and then select that ping pong sound. And for the location, we can just right click and look for get actor location and just connect this into here. And if we go compile, play, whenever I hit the ball, it plays that sound. Also, one more thing, you may notice when you click the game, you need to click the mouse button in order to start controlling the character. In order to make it so we start playing our game instantly, just head over to the paddle blueprint and event begin play. We just want to right click and look for set input mode game only. Connect this into here. And then just right click and look for get player controller and connect this into here. Then if we go compile and we play our game, we'll instantly start playing our game. Then finally, let's go over how to add a main menu to our game. So I'm just going to right click, go user interface, select a widget blueprint, select user widget, and I'll just call this my main menu widget blueprint. I will open this up, and in the palette, if I look for a canvas panel and just drag this in here, then I'm going to look for some text. I will anchor this to the top of my screen, and I'm just going to make this text say Pong. I will make this 120, so it's a bit bigger. And then in the palette, if we look for a vertical box, I will anchor this to the center of my screen. And then I'm going to look for a button, and I'm going to drag 2 of these inside of the vertical box. Then I'm going to look for some text and place a text in each button. For this first text, I'm going to make it say play. For the second text, I'm going to make it say quit. And I'm going to select both of these texts and make them a bit bigger. And I'll add some padding to the first button. So let's add a padding of 200. Actually, I'll make it 100. Okay. And then we just want to select both of these buttons and make sure this is variable checked. And just call this the play button. And we can call this the quit button. So I'll make sure it is a variable and call it the quit button. When the quit button is clicked, so if we scroll down, go to events and go on clicked, we just want to drag off here and look for quit game. This will quit our game. And then in the designer, when we click the play button, when we click it, we can just drag off here and look for open level by object reference. And the level we want to open is going to be the, I can't remember what we called it. I think we just called it level. Let me just double check. Yeah, so it's called level. And then if we just compile this, we're going to create a new level for our main menu. So I'm just going to save this, go file, new level, and select an empty level, create. And in this level, if we just go open level blueprint, event begin play, we want to create a widget, and that widget is going to be the main menu. And then we will add this to a viewport. We will compile it, and then our main menu also needs a game mode, but this can be very simple. So we can just right click, go blueprint class, and select game mode, and just call this the main menu game mode. It doesn't need a character, so if we just go to world settings, and we can just drag this here. And then one more thing with our main menu, if we just head back to it, we want it so our player will be able to basically click and interact with the main menu. So to do this, we want to make sure that the mouse cursor is showing. So if we just right click and look for get player controller, and just drag off here and look for set show mouse cursor, make sure this is checked. This is basically make it so we can see the mouse cursor. And then we just want to drag off here and look for set input UI only. This will make it so we can interact with the main menu. And now if I go compile and play, when I'm in this level, if I click quit, it will close my game. But if I click play, it will take me to my Pong. Nice. And then one more thing, if we just go back to our win screen, then if we go back to the score widget blueprint, when the game is over, let's give the player the option to go back to the main menu, or to just quit the game. So I'm just going to go to my palette and look for a vertical box. I will anchor this to the middle, and to save time I can just go to my main menu and I can just copy both of these buttons with the text. So I've just selected everything, and then inside here, if I just press Ctrl V, I'll basically paste that inside of here. And I'm actually just going to make this a retry instead of quit, because yeah. And then if I just select this quit button, when we click it, we want to quit the game. And when I click this retry button, we want to go here, open level by object reference, and we want to open up the level again. And then we also want to just select this vertical box, make it a variable, and just call this buttons, and we want to make sure that this is not visible. So let's make sure that this is hidden when it's initially on the screen, and then only when one player wins we will make this visible. So I'll just drag in the buttons here, and before we pause the game, let's just look for set visibility. Actually, we can just connect the buttons into here, and I will just also drag in the buttons variable again and connect it into here. And then one more thing, when we basically show our buttons, I want my player to be able to interact with them. So I'm just going to go back to my main menu and copy these nodes here, and I'm just going to paste them before we pause our game. And then I will just compile that. So when either player wins, this will appear. So I'm just going to change this to be 1, just so I can test it. So let's say player 2 wins, then I can retry or quit. Maybe I can change the color of these buttons as they're kind of a bit off, but hopefully you understand the code and the logic behind it. And then we just want to save this, and we just want to call this our main menu level, and just save this. Hello, the next thing we're going to cover is how to export and share the game. If we just go over here where it says edit and go to project settings, go to maps and modes, and we want to go to the game default map. This is going to be the first map the player sent to when they open our exported game. We want to change this to be the main menu. Then if we go over to the editor startup map, this is going to be the map we are taken to when we first open up our Unreal Engine project. You can just change this to be whatever you want. So once you've set up the game default map, you can go over here where it says platforms, and then you just want to go over to Windows and go package project. It will ask you where you want to package your project, and then I'm just going to select my desktop, and then I'll start to export and package your project there. Also, it may not let you package your project if you don't have Visual Studios with for game development. So if you don't, install Visual Studios with the game development, and then you should be able to package your project. Okay, so my package has finished exporting. Here it is, it's in this folder called Windows, and if I just open it up, I'm taken to my main menu level, Pong, and I have my Pong game. Hello! So the next thing I'm going to do is actually polish up the windscreen. If we just head over to the score widget blueprint, go over to the palette and look for a blur. And we want this one, background blur, just drag it somewhere into the canvas panel. And for the anchor, select this one in the bottom right. And for the offset values, just put 0 in each value. Now, if I increase this blur strength, we can see the screen will get blurry. So I want this to happen when one player wins. Although you may notice, this blur is kind of covering everything. With UI elements inside of Unreal Engine, we can control their Z order. So right now, everything is on the 0 Z order. If I just select this background blur, its Z order is 0. And I want my background blur to be behind every other single UI element. So for the Z order, if I make this -1, when I increase the blur strength, it's only going to blur everything behind it. And this is exactly what I want. So now that we've done this, if we just check this is variable, then head over to the graph. When either player wins, we can just drag in the background blur, get it, and just set the blur strength And let's just set it to be 35. And I'll just connect both things into here. And for testing purposes, I am just going to make the score 1 again. Okay, looks like I already did that. So if I just go compile and go play, if I let one person win, we can see player 2 wins, and then it's a lot clearer, basically. So that's all for this tutorial. I hope you've enjoyed. And if you want to learn how to create even more full games inside of Unreal Engine, check out my website. It has a bunch of different courses there.